Welcome to another session of ID 75. This program is structured to commemorate 75-year Independence Day celebration as a part of DBT Science Setu program. Today we have with us Dr. Prem Kaushal, who is Assistant Professor at RCB. Dr. Kaushal will showcase the life and journey of eminent scientist Dr. G.N. Ramachandran. In fact, Dr. Kaushal did his PhD from Molecular Biophysics Unit, ISC Bangalore, which is one of the department that is started by Dr. G.N. Ramachandran. Sorry. So post his presentation, we will showcase the facilities at RCB, and post that there'll be a question and answer session for which Dr. Prem is with us. So do post your questions in the comment box for that. And now, without further ado, let's invite Dr. Prem for the presentation and the webinar. Thank you.
Thank you, Dr. Nidhi. Let me first share my screen. This is with sound. I hope my screen is visible and I'm audible to all of you.
Yes, sure.
Yeah. A very good morning. I would like to thank Coordinator and Executive Director of the RCB to giving me this opportunity to talk the life and work of the great Indian scientist whom I admire most is G.N. Ramachandran. Gopala Samundram Narayanan Ramachandran, often called GNR respectfully and affectionately. I have shown two of his pioneer work, one on the left-hand side, that is the triple helix, and on another hand side is the Ramachandran plot. G.N. Ramachandran was born on October 1922, Ernakulam, Cochin, Kerala, to G.R. Narayanan, father, and Lakshmi Amal, mother. His education intermediate was from Maharaja's College from Ernakulam, where his father was a professor of mathematics. Later, he became the principal of this college. Ramachandran completed his BSc in physics from St. Joseph College, Tiruchirappalli. And obvious choice for higher education that time was Indian Institute of Science, Bangalore. And Ramachandran joined electrical engineer department, and there he came in contact with Sir C.V. Raman, then the director and the only Nobel laureate from India in science for his Raman effect. Now, the Raman want to admit Ramachandran to his department, and he requested head of the Department of Electrical Engineering. When his request was repeatedly turned down, so he wrote like this: I am admitting Ramachandran to my department as he is a bit too bright to be in yours. And he was admitted to Department of Physics. He finished his master's in 1944 and DSc in 1947. And then Ramachandran, on a 1851 execution scholarship, Ramachandran joined Cavendish Laboratory, University of Cambridge, UK. There, that time, the head of the Cavendish Laboratory was Sir William Bragg. And William Bragg, with his father, Henry Bragg, gave the Bragg's law that gave the worth of the X-ray crystallography and was awarded Nobel Prize. There he came in contact with Linus Pauling, that time was a visiting professor. Linus Pauling is won 2 Nobel Prize, one in chemistry for valence bond theory, another in peace. Another eminent Nobel laureate that time in Cavendish was Max Perut, Nobel laureate for hemoglobin structure, and John Kangaroo, Nobel laureate for myoglobin structure. And Raman was very much influenced by their thinking process, the way they tackle the problem, etc. And Ramachandran, Ramachandran earned his PhD in 1947 with W.A. Wooster, another eminent crystallographer of that time. And Ramachandran's public work, PhD thesis some of work was published in high impact factor or top journal of that time. Even today also, the same journal is at top ranking even today. Now, in 1949, Ramachandran returned back to IISc Bangalore, joined as an assistant professor, and established X-ray crystallography laboratory. This is the young Ramachandran with another bright postdoctoral fellow, Gopinath Kartha. Gopinath Kartha was a brilliant postdoctoral fellow. Later, he solved the first structure of ribonuclease that in United States. That was the first structure in United States solved by Gopinath Kartha. And now, sorry, I need to move forward. So now there is a move from Bangalore to Madras. Then comes the Professor A.L. Mudliar, then Vice Chancellor, visionary educationalist, was looking a suitable person to start the Department of Physics at University of Madras. Mudliar wrote to C.V. Raman that if you please join as a head of department, as a professor at University of Madras. Raman wrote back that I am retired now, I cannot be a professor anymore, but I am recommending the person who is equally competent like me, that was the G.N. Ramachandran. And in 1952, Ramachandran joined University of Madras as a founder head of Department of Physics. At the age of 30, he was full professor. And later, the Center for Advanced Studies was established. Now, Ramachandran has certain ideas, but what problem to take first and where to start. Then J.D. Bernal visited University of Madras in 1954. And in a casual conversation, J.D. Bernal told that the collagen structures, whatever are proposed so far, are not satisfactory. So Ramachandran thought that may be the good idea to start with. Now his focus shift is to start the collagen structure. Let's try to understand, let's know a little bit of collagen. Collagen is the main component of connective tissue such as cartilage, bone, tendon, ligaments, and skin. It is the most abundant protein in mammals, making up to 25 to 35% of whole body protein content. And mutation in collagen is responsible for the diseases like osteogenesis imperfecta, chondrodysplasias, and Ehlers-Danlos syndrome 4. And it has a wide application used in cardiac application, cosmetic surgery, bone grafting, tissue regeneration, and artificial skins in case of severe burn and wound. Now where to get the sample of the collagen? Next door was the CSIR Central Ladder Research Institute, and they started with this sample from the rat tail tandem, but diffraction was very low. Then comes the Professor Nayudamma. He was the director of this institute at that time, and he realized what kind of sample Ramachandran is looking for. And that sample was finally taken from kangaroo tail. Professor Nayudamma went for some visit to Australia and brought one kangaroo tail, and that were isolated. And there is a secret behind the kangaroo tail. These red kangaroos can reach a speed of more than 35 miles per hour. They can also cover an area of 15 feet long and get up to 6 feet height in one jump, using their tail like a spring to give them more power. So this was the perfect sample because it's a strong collagen and gave the better diffraction. But this is a fiber diffraction. You see, this is a very limited data, and you have to build a structure from out of this diffraction pattern, and that is really a Hercules task. Professor G.N. Ramachandran, with this limited data and lots of insights and intuition, proposed first structure of the collagen in 1954, and later here it shows that it has the three helix are arranged by a 120-degree angle, but later the angle was improved. It turns out to be 110, and this is the final model was built based upon all these limited data resources and with lot of, as I said, intuitions and imagination. So the smartness here is, it was known that a third of collagen sequence is made of glycines. From this information, Ramachandran and Kartha made the assumption that every third residue in polypeptide chain was a glycine. So everybody thought 1/3 is the glycine, but Ramachandran put every third residue as glycine, and that's why all the third residue came in the core of the helix, and he could build the accurate structure. So now the structure of collagen became easily understand following the textbook, and this is a single collagen, single helix of the collagen. It is alpha left-handed. If you see the rise in the pitch of the helix, it is towards the left. It is a left-handed. And if we look into a space-filled model, it looks like this. And three helix, they form a coil around each other. They coils around each other, and this is actually the collagen structure, coiled triple helical structure. And if we look into from the top of this molecule and highlight all the glycine residues in red, the core of the helix is there, only the glycine residues are there. Now there was a collagen controversy, 1 versus 2 hydrogen bond. This is very important. So Crick and Rich, Francis Crick and Alexander Rich, published paper simultaneously with Ramachandran's 1955 paper. He, at the very beginning, he says, very recently, Ramachandran and Kartha have made an important contribution by proposing a coiled-coiled structure of collagen. We believe this idea to be basically correct. They accepted the coiled-coiled structure of collagen is correct, but the actual structure suggested by them to be wrong. And there is the difference is 1 versus 2 hydrogen bond. And okay, let me discuss here. Ramachandran and Kartha propose that there is a intrahelix 2 hydrogen bond, But the Crick and Rich said if there is two hydrogen bonds, the atom will be coming very close to each other and they will be colliding to each other, and that is not possible. And the assumption they made was no two atoms can come closer than their sum of their van der Waals radii, and uh, and that was the basic assumption. And they proposed a single hydrogen bond, and this led to think Ramachandran even very deep and go into the heart of the problem. And one of his paper in later, he showed indeed there are two hydrogen bonds, but one hydrogen bond may be through the water-mediated, this one here, water-mediated hydrogen bond, the hydroxyproline that has OH, that forms the hydrogen bond. But there is an official record that says when Ramachandran submitted his second paper to Nature Journal, it is from London, the editor sat on the paper and gave access of this paper to the Rich and Crick, so they can work out on their manuscript. And Gopinath Kartha was that time in London, and his personal communication to Ramachandran clearly says that the idea is to put on hold G.N. Ramachandran's paper and let them Crick and Rich to work, and paper were published simultaneously. The Ramachandran paper was published after 5 months, whereas Crick's paper was published within a month of submission. But this thing did not demoralize Ramachandran. His enthusiasm for science, it was same, and he started thinking even deep. So here I want to make one more point. That is, sorry, I moved. Okay, so later with the high resolution crystal structure, and cryo-EM suggested that it's a dynamic structure. There may be one hydrogen bond is always there. Second hydrogen bond is through the this water-mediated hydrogen bond. Now this gave rise to another piece of work, another important piece of work, that is Ramachandran plot. Now Ramachandran asked question, how close the two atoms can come in a protein structure. And because the van der Waals radii are determined in gaseous state, that may not be correct when their atoms are covalently bound. And later it turns out that two atoms can come closer than the van der Waals radii, and the assumption of Crick and Rich was wrong. Now, let's try to understand a little bit here. This is a polypeptide, and dipeptide, if you can repeat dipeptide and generate any protein in this universe, and dipeptide has this amide bond between C and N here, and this is partially double bond here, and it will always be flat. There will not be a rotation possible in this bond. However, there are two bonds. There is one is phi, and that is between nitrogen and C alpha, and another is psi, that is between C alpha and C. Rotation in a peptide is possible only between two angles, and if we keep on rotating and see how much rotation is possible before there it doesn't collide with any other atom, and they calculated and made this Ramachandran plot, and they showed only these angles of phi psi combination is possible, otherwise it will make a steric clash, it is not possible. And this plot put a 3-dimension problem of this into 2-dimension problem. Its significance was people realized then myoglobin structure came at 2.8 angstrom resolution, and they plotted the phi-psi angle that nicely fitted into this region. And let's see little bit of more, understand what is this phi-psi. Now that it's a textbook material and we can easily understand going through the textbook. That's what I showed you. This is a phi angle and psi angle. This is peptide bond. It is always plane. So rotation is possible here and here. Actually, these are the rotation torsion angle. Basically, the angle is measured between the plane of 3 atoms, like carbon, C alpha nitrogen, and C alpha nitrogen carbon here. So these torsion angles are basically the angle between the plane of the atom. And if we fix, say, like psi and rotate the phi, you will see at certain rotation, it is going to collide. This confirmation is not allowed, and only this confirmation is allowed. That's what Ramachandran plot tells us. The student behind the Ramachandran map was C. Ramakrishnan. It is worth mentioning here. C. Ramakrishnan did all this calculation. You fix one angle, say phi, and rotate psi around 360 degree and calculate the position of atom and see whether they are colliding with each other or not. And basically he did 360 into 360 calculation, 360 into 360 time calculation. And it's said that it took Ramakrishnan full 1 year, means he did 360 calculations per day. And there was nothing fancy computer program. It was the simple calculator. This is the calculator. It can do only 4 functions: addition, subtraction, multiplication, and division. Rest everything he has to note it on the paper and make big file. And there is an interesting story of computer also. When G.L. Ramachandran solved the structure of Collagen, and J.D. Bernal wrote a recommendation letter to Prime PMO that Ramachandran is doing extraordinary work, great work, and he should get a computer. But in meantime, he got this computer from UNESCO. Now it comes, what is the use of Ramachandran plot? If we look today, there are 1,80,419 structures deposited in PDB, right? And it means this map was used to confirm the correctness of 1,80,419 structures. Before submitting coordinates to the data bank, everybody has to fix the phi-psi angle. They should be allowed or partially allowed region. People try to build their model, check for Ramachandran plot, and change the phi-psi angle and check. Suppose Ramachandran map was used 10 times on an average before depositing coordinate to the data bank. It means this map was used 18,04,190 times in last 50 years, because PDB is celebrating its 50 years. So on an average, this map even today is used 100 times per day. The application or importance was more became more visible when the synchrotron became available, and people started solving the structure. There had been a lot of incorrect structure were deposited. So they put a filter that everybody has to pass Ramachandran test. Apart from this was the major pioneer work. Ramachandran also discussed about the anomalous dispersion or phase determination. It is when X-ray hit to the molecule or to crystal, it scatters. But at particular wavelength, its scattering is anomalous. Means, if I put a simple analogy, suppose in stadium there is a race going on, and everybody is running. If the stadium light, you change the light, you make it dim, and those who have the little poor eyesight, they will slow down. So basically, same thing happen at certain wavelength. There is a phase shift, and that phase shift can be used for phasing to determine the phase in X-ray crystallography. And this structure, it was proposed in 60s, but that time there was not a source that can twin the X-ray wavelength, and that came possible only once the synchrotron was possible. There you can change the wavelength. Apart from this, J.N. Ramachandran also evoked the discussion on CHO bond. You see we know that there is a hydrogen bond, CNO, but there is another CHO bond also. Apart from this is a very only few people knows. When Ramachandran was a visiting professor at University of Chicago, Department of Physics, he came up with 3-dimensional reconstruction for radiograms and electron micrographs. He applied the convolution instead of Fourier transformation. And later, the same method was the basis for development of MRI and CT scans. Ramachandran he returned back in 1971 from Madras University. By that time, the vice chancellor changed, and the next vice chancellor could not keep the research environment what Ramachandran really likes. So he decided to move to the ISC, and he founded molecular biophysics unit department in 1971. I was fortunate enough to earn my PhD from this department. Ramachandran attracted Nobel laureates. He conducted international symposium. The one is in 1967 in Madras University, Linus Pauling, Dr. Hodgkin, the Nobel laureate for vitamin B12. And the same tradition of attracting eminent scientists, Nobel laureates, continued in IISc Bangalore also in 1973. Dr. Hodgkin was there. Ramachandran was a great teacher also. See, if you see here, Ramachandran drew a helix. Basically, it is a left-handed helix. It's not right-handed helix that is present in protein. And he drew a helix, left-handed helix, then asked students to imagine and propagate their imagination towards his left-handed triple helix structure. As a great teacher, a great poet, he wrote a lot of poems. One of poem is here that he wrote on Linus Pauling. Ramachandran married to Raja Lakshmi, and his 3 children, they are the top professors in top universities in India and abroad. So he was a great father also. He was a fellow of almost all three National Academy, this Third World Academy, and more importantly, the fellow of Royal Society. Ramachandran won the various awards and distinctions, starting from Shanti Swarup Bhatnagar to the Ewald Prize. Ewald Prize is the topmost prize given in the field of crystallography by International Union of Crystallography. And for Ramachandran plot, he was awarded with the prize. Ramachandran passed away in April 7, 2001. Obituary was written in almost all top journals. Nature says that a renowned crystallographer and structure biologist, NSMB, then in structure, his student C. Ramakrishnan, that I discussed, wrote obituary in protein science, and editor clearly put a note on top of that. This is important. Few scientists contribute an idea of such clarity and power that it appears in all disciplines, textbooks, and bear the author's name. Then here in perspective, he writes, no biochemistry textbook is complete without 5-cell plot of alanine dipeptide, or more precisely. And leading scientists from Europe, including Professor Linus Pauling and Professor Francis Crick, regard Professor Ramachandran as a Nobel Prize caliber scientist of great reputation. Yeah, Ramachandran has left, just let me see. Ramachandran has left behind a rich legacy. His achievement will serve as a source of inspiration for generations to come. He was undoubtedly one of the most outstanding scientists of post-independent India and a jewel in the crown of Indian science by P. Balaram, former director, IISc Bangalore. Here is Ramachandran's voice.
In Madras University in 1952. I chose X-ray diffraction and X-ray crystallography in particular as the main theme for the laboratory, and the applications to biomolecules as the main aspect of this field that is to be pursued rigorously. However, I did not know where to begin, and on which molecules and biopolymers are the most profitable ones to study. The problem was resolved by the happy coincidence of visiting Professor J.D. Bernard to Madras during this. When I put this question to him, he told me that he was not very happy with the various structures of collagen that had been proposed in the literature at the time, and that the problem was wide open.
That is Ramachandran. And here is eminent scientist view about Ramachandran.
To give G. N. Ramachandran great credit, because Ramachandran actually created a first-rate environment.
He always felt, I think, that we should be as good as anybody else in the world. Ramachandran and team did not complain that, they don't have computers to do it, they don't have facilities. They just wanted to do it.
Somewhere around there is when he started developing some psychological problems. With all that he was managing, none of it stopped his work.
GNR was bent on proving that he was right.
Basic idea about the triple helical coiled-coiled structure was Professor Ramachandran's. There's no doubt about it.
But then comes the Ramachandran plot.
Probably if today we talk about bioinformatics as an area, perhaps he's the originator of bioinformatics in that sense through his so-called Ramachandran plot.
The Ramachandran plot became central to my thinking and my life in structural biology.
And these are the references. I strongly recommend these two documentaries in YouTube. Everyone should watch this. and these are the coordinator of our Science Setu program. Thank you very much for your kind attention. I will stop screen sharing, and now we will take you to RCB's documentary, about the RCB documentary. Mr. Gaurav, you may play now the RCB's video.
Regional Center for Biotechnology is located in a tranquil environment along the Gurugram-Faridabad Expressway. It is an autonomous institute established under auspices of UNESCO by the Department of Biotechnology, Government of India. The primary focus of RCB is to provide world-class education, training to create high-quality human resource in biotechnology, and conduct innovative research at the interface of multiple disciplines. The infrastructure at RCB has developed at a rapid pace since inception of the institution in 2010, with state-of-the-art research labs, teaching labs, innovative classrooms, central instrumentation facilities, small animal facility, biosafety level 3 facility, a biorepository, and state-of-the-art advanced instrumentation facilities like the Advanced Technology Platform Center and a bio-incubator, which serves as a reservoir for incubating ideas in the area and help them reach commercialization. There are various areas of research in RCB. The research group under the area titled Cell Biology, Development and Behavior focus on unlocking the secrets of cells, how they divide and how stem cells develop into muscle, in addition to studying the cellular and molecular origins of how organisms behave. Areas of agricultural biotechnology aim to tackle some issues by harnessing the existing genetic diversity in plants and their inherent capacities to adapt to abiotic and biotic stress conditions in order to develop innovative and durable methods of crop improvement. Groups working on infectious diseases, both bacterial and viral, aim at developing novel therapeutic strategies against infectious agents using tools such as mass spectrometry and microscopy. These researchers will shed light on cellular and molecular basis of bacterial infection and the response of the human host towards these infections. They are trying to find novel solutions to protect the people against diseases such as chikungunya virus, Japanese encephalitis virus, and dengue virus. Protein structure and design groups are structural biologists who have a molecular view of life and use cutting-edge methods like macromolecular X-ray crystallography or cryo-electron microscopy to imagine biological molecules in their functional state. This information is used to develop novel therapeutic strategies against pathogenic bacteria and viruses, and for protein engineering to prepare molecules with desired properties. Researchers at RCB are also working towards developing innovative biotechnological applications such as novel drug delivery systems, new diagnostic tools, novel engineered protein with improved desired proteins, and improved methods to obtain desired products in large scale. These researchers subject laboratory and clinical samples to cutting-edge microscopy, proteomics and genomics methods coupled with flow cytometry to shed light on the etiology of disease and utilize this knowledge to identify solutions to these disorders. The quality of research conducted at RCB is excellent, with faculty winning top honors like the Shanti Swarup Bhatnagar, the National Bioscience, the Innovative Young Biotechnologist Awards, and the Ramanujan Ramalinga Swami and DBT Welcome Alliance Fellowships. Since research-based learning is the hallmark of RCB, the academic programs here are deeply enmeshed with the research programs. The academic programs fulfill RCB's core mandate to provide quality education and training in the area of life sciences and biotechnology. The PhD program in biotechnology is for students who are interested in working at the interface of multiple disciplines to find novel solutions for problems in health and agriculture. RCB has recently started integrated PhD program in biotechnology, offered to students with graduate degree in any discipline of science from India and abroad. The program provides extensive learning opportunities in the broad field of life sciences and biotechnology. RCB has also recently initiated an interdisciplinary doctoral programs in the area of biostatistics and bioinformatics through collaboration with the global pharmaceutical giant GlaxoSmithKline (GSK), being conducted in partnership with other institutions by creating a virtual faculty pool. The focus of this program is on creating specialized manpower for the healthcare industry. As an outreach activity, RCB also offers research training programs for research-driven undergraduate and postgraduate students of science from various universities. Trainees get a realistic experience of several facets of modern biological research that sets the tone of their embarking on a research career. Throughout the year, RCB hosts and organizes regular academic events like the RCB Bioimaging School, national and international conferences, seminars, symposia, and training in the frontier area of basic and applied sciences in topics such as infectious diseases, drug discovery, etc., to disseminate advanced knowledge, exchange ideas, foster national and international collaborations, student exchange, and networking opportunities. RCB also holds scientific communication and communication workshops for the benefit of young scientists in India. RCB has a fully functional library and houses 500 scientific textbooks and 100 administrative books in multiple copies. In addition, an electronic library provides access to a vast range of primary literature in the form of peer-reviewed journals and reviews. RCB offers faculty residences and excellent students' facilities, including on-campus air-conditioned hostel accommodation, modern library, meeting rooms, seminar rooms, and auditorium. The hostel and student facilities are conveniently located and only a short walk away from the classrooms and laboratories. In addition, the campus also has sports and recreation facilities which encourages all-round development of the students. Campus also provides a childcare facility for all students and staff to help them continue their studies and work while their babies are being taken care of. Kridangan, the creche, housed in the faculty building, is an asset on campus for employees of NCR Biotech Cluster. The spacious cafeteria in the campus serves hygienic, nutritious, and delicious meals and beverages at reasonable cost. RCB also contributes towards creating resource for researchers from all over India and has engaged with institutions such as the European Synchrotron Radiation Facility in France towards this end. RCB is also involved with the UNESCO towards developing policy to ensure sustainable development at the global level and specifically in the Asian region. RCB is a young institute which is growing day by day with excellent opportunities for young people to make a career in the area of biotechnology.
Thank you very much for, I hope you enjoyed RCB's documentary as well. You can ask your questions by typing that in chat box. In meantime, I have received 2 questions. First is Ramachandran map only criteria to check if structure is correct? Apart from the 5i angle, the correct values, one need to check short distances, that atoms are not too close, and also need to check the rotamers and bond standard deviation from bond length as well as from bond angle. Another question what I received is, was G.N. Ramachandran as a Nobel laureate? Unfortunately not. He was nominated one time for sure by Raman. But yeah, there is a lot of people discuss, you see a lot of literature that says, yes, Ramachandran should have got, the Nobel Committee should have recognized his work. It is so fundamental and basic, recognize his work in the form of Nobel Prize, but that did not affect his work. And there is so many things, literature, in so many times he said that it means he has not complained as such that I was not given the due recognition in the form of Nobel Prize. And even if you check, there's no, the Padma Award also, he was never considered for the Republic Day award. And that is unfortunate in Indian part also, after doing such a tremendous or such a basic work, even Government of India has not recognized him. That's all. Thank you. Have a nice day. Bye.